Okay, now we're going to talk about even and odd functions. I love talking about even and odd functions. I think that the work for this is so cool, especially once we get into the tests to figure out if a function is even or odd. I'm a huge math nerd, so I guess that makes sense, but hopefully you guys will enjoy this too. So, all right, even and odd functions. We'll take a look at some even and odd functions on the next page. Um, and we're going to dive way more deeper than what's written here. But what this is saying in red here is um, if we want to test for an even function, we can take our input x and change it to negative x and examine what the output is. So what this is saying, in order for a function to be even, um, opposite inputs, so x and negative x, generate equivalent outputs. Right? So whether you plug in x or negative x, you're going to get the same output. So if you plug in 2 and negative 2, both will generate the same output. If you do negative 11 and positive 11, they'll both generate the same output. And that's going to create some symmetry over the y-axis because you'll have like 2 and negative 2, and they'll both have the same height. Then you'll have like 1 and negative 1, they'll have the same height. Okay, so we'll take a look at a few examples, and that's a lot easier to see. So for an odd function, okay, if f of negative x equals negative f of x, the function is odd. What does that mean? So what we're saying here is if you have an input of x and an input of negative x, so opposite inputs, same test as the even function, they're not going to have the same outputs. Now they're going to have the opposite outputs, right? That's why that negative is in there. So whether you plug in x or negative x, they're going to generate opposite outputs. One will generate f of x, the other will generate negative f of x. Odd functions have what we call rotational symmetry of 180 degrees around the origin. It is completely fine if you are nothing but confused right now. I'll try to clear it up over the next couple pages here. Okay, so the first thing we're going to talk about here is even functions. So we're going to look at this even function, f of x equals the absolute value of x. And to do that, we're going to look at 6 different inputs, 2, 3, 4, negative 2, negative 3, negative 4. So I split it up into 2 different tables. And let's look at the outputs when I plug in the positive numbers. So absolute value of 2, absolute value of 3, and absolute value of 4. Outputs don't change, right? Okay, now let's plug in the negatives of all those. Absolute value of negative 2 is 2. Absolute value of negative 3 is 3. Negative 4 is 4. So what we can see is when I plug in the original 2, 3, and 4, or when I switch it to negative 2, negative 3, negative 4, the outputs are unaffected, right? The outputs are the same regardless. And that's because the nature of this function is that it always is going to turn it positive. Okay, so with respect to the above function, what's the relationship between f of x and f of negative x? Well, this is what we said on the other page. F of x equals f of negative x. The outputs from x are identical to the outputs from negative x. Okay, so that indicates an even function. So even functions are symmetrical over the y-axis. So let's take a look at 3 different even functions. So the one that we just looked at is f of x equals the absolute value of x. This is probably your most common one in the middle, x squared. And then cosine of x is another one. There's a million of these. I've counted them. So let's look at this. Let's look at inputs of 1 and negative 1, right, for x squared. So 1 gets me an output of 1. Negative 1 squared is also 1. So that's where that symmetry comes from, right? You're going the same distance left and right, and both of them have the same height. So it creates like a mirror image. When I square negative 2, I get 4. When I square positive 2, I get 4. Again, those are mirror images over the y-axis, right? 3, 9 would be somewhere up there. I'm sorry, negative 3, 9. And then 3, 9 would be up here. Same thing. So that's where you get that symmetry from. Opposite inputs have equal outputs. Okay, so now we'll look at a common odd function, f of x equals x to the third, and we're going to look at those same 6 inputs that we looked at from the previous example. So 2, 3, and 4, positive and negative. So let's cube all these values. 2 cubed is 8, 3 cubed, 27, 4 cubed is 64. Now, if this were even, I should get the same outputs, right? So let's see what happens. It's odd. When I cube negative 2, that's negative 2 in parentheses, and then to the third power. So negative 2 times negative 2 is 4, times another negative 2 is negative 8. Okay? Negative 3 cubed, negative 3 times negative 3 is 9, times another negative 3 is negative 27. Negative 4 cubed is going to give me negative 64. So let's look at what happens here. When I plug in x, I get a set of outputs. Then if I plug in the opposite of x, I get the opposite of my outputs. Okay, so even would have generated positives of all these, right? So they would be identical. Odd generates the opposite of those. When you change the sign on your inputs, you're also going to change the sign on your outputs. Okay, so the characteristic is that we have symmetry around the origin, and it's 180 degrees. So we spin a half circle, and it's going to land right on top of itself. So here's 3 odd functions. F of x equals 1 over x. The one we just talked about, f of x equals x cubed, and then your sine of x function is also an odd function. So let's look at x cubed. So when I cube, this is kind of tough to see with the scaling, but where's 1? I think that's an input of 1. So when I plug in 1, I get an output of 1. When I plug in negative 1, I get an output of negative 1. Okay, when I plug in 2, I get an output of 8, which would be somewhere up there. Negative 2 gives me an output of negative 8. Okay, and when we continue, we see that it's basically, if I spin this around, right? If I take this and spin it that way, and I take this part and spin it that way, if I go 180 degrees, a half circle, it's going to look exactly what it looks like at the beginning. Okay, so that's an odd function. Okay, now this is my favorite part. So let's get to actually doing these tests. I think I have 6 examples. I don't know if I'll get through all of them, 5 examples, but I'll do my best. So first, let's do what's in blue. So I'll do all the problems in blue. So there's 2 options for testing to see if you have an even function, an odd function, or neither. Most functions are actually neither in reality. So what you want to do, you're given f of x for all these. You want to plug in f of negative x, simplify it, and then analyze the results. If you have the exact same function you started with, then it's even. If you're the opposite of the function you started with, then it's odd. And if it's neither of those 2, then it's neither. So f of x equals x squared plus 1. All right, so let's do f of negative x equals, I switch my input to negative x, I'm still squaring it and adding 1. Negative x quantity squared is x squared, plus 1 is unaffected. X squared plus 1, x squared plus 1, so that equals my original f of x. That's even. Okay, let's look at B. F of x equals x. Let's plug in negative x. So that's going to change to negative x. Is that the opposite of your original function? Yeah, I would say that x and negative x are opposites. So this is odd, right? Switching the sign on my input, also switch the sign on my output. Okay. Question C. F of x equals x plus 1. Let's do f of negative x. So that would equal negative x plus 1. Drop the parentheses. Is that the same? Is x plus 1 the same as negative x plus 1? I would say no. That's not the same, so it's not even. Is it odd? Is that the opposite of what we started with? Is that negative 1 times what we started with? No, it's not. I need to have all signs switched, but I only switch the sign on the x, right? What I need to have is like negative times my original function. Well, this would give me, when I distribute, that give me negative x minus 1. I have negative x plus 1, so this is neither. Okay, part D, f of negative x equals 1/2 times negative x cubed. Exponents come first. So 1/2 times negative x, negative x, negative x. These two negative x's multiplied give me x squared. So I have 1/2, and then x squared times negative x is negative x to the third, which is negative 1/2 x to the third. Is that the same as what I started with? No. Is it the opposite? Sure is. But this is odd. It is negative 1 times my original function. Okay. 3x squared minus 1. F of negative x equals 3 times negative x squared minus 1. Negative x quantity squared. It's just positive x squared. That's the same. That's even. Okay, now let's go back, and I want to show you a second way that you can do these, and I think this is the quickest way. Okay, this is what I really like. So now I'm just going to look for exponents on all my variables, and if all of them are even, it's even. If all of them are odd, it's odd. However, anytime you see a constant, if you have like a plus 1 at the end, like I'm going to have with question A, you must attach x to the 0 power to it. Every single one of these has to have a variable with a exponent attached. X to the 0 is equal to 1, so this is really the same as just plus 1, but that's what we got to do in order for this test to work. So this function, when I attach x to the 0, is what? X squared plus 1x to the 0. Once I get to this point, look at all your exponents. They are both even. That means this is an even function. We knew that. Okay. Let's look at the next one. F of x equals x. So f of x equals, that's really x to the first. I don't have plus a constant, so I don't need to attach x to the 0 to anything. My only exponent is 1. That is an odd function. All exponents are odd. Part C. F of x equals x plus 1, so that's x to the first, plus 1. I have to attach x to the 0. Let's look at all these exponents. Okay, so since I have one of each, that's neither. Okay. Question D. F of x equals, well, I don't have to change anything there. There's no constant. That's odd. That's the only exponent. So this would be odd. And the last one, by adding x to the 0, we see that that is going to be even as well.